Alright, welcome back. Today we're going to go over Chapter 3. It's all about shielded metal arc welding. This will be primary, we'll be going over Chapters 3, 4, 6, and 28. To get things rolling, first of all, what is shielded metal arc welding? Typically it's represented by SMAW, also commonly known as stick welding. So what does SMAW stand for? S stands for shielded. What's shielded mean? That actually means my electrode, my filler metal, it's going to have a flux coating over the top of it, and that's what they're going to be using to shield our weld. You notice in GMAW, it was gas metal arc welding. Well, for shielded metal arc welding, we are not using any gases at all. All the shielding gases are going to be provided from the flux when they actually melt off your electrode. So, flux coating right here on your electrode. Same as GMAW, we're going to be using metal. We use both non-ferrous and ferrous metals. One good thing about SMAW, if we're going to switch to aluminum, we don't need to change any gases or anything. We use an aluminum electrode or a stainless steel electrode or carbon steel electrode. You just stick a different electrode in, weld it, and you can weld just about any types of metals. This is arc. Arc means we do need electricity for this process. So you need some sort of a power supply. And welding. Welding's simple. Basically just fusing two metals together. So that's kind of a breakdown of SMAW, what it actually stands for. Shielded metal arc welding. It's a little bit different than our wire feed process. This process here is it's not semi-automatic. This is a manual welding process. So what does that mean? It's a manual welding process. So that means you control basically everything. How much of the stick electrode you're actually sticking into the metal, your angles, your travel speeds, things like that. So this is a manual welding process. So when we start talking about stick welding, we are using what they call amps. Now in GMAW we use volts. What are volts and what are amps? So when we talk about volts and amps, volts actually pushes the current through. Amps is the amount of current. So when you're in your wire feed process, GMAW, you are adjusting your inches per minute in your volts. So when we get into SMAW, you basically have one setting, and that's your amps, the amount of current that we're going to be using. For this welding process, usually we use what they call constant current. So that means when you set your welder up to 120 amps, you're welding with 120 amps. It's constant. Where in your GMA welding process, you're using voltage. How much force are we putting behind our current? So that's where your wire feed speed comes into play. So volts, keep in mind, volts actually push the current through. Amps is the amount of current. When you start looking at this, think of it as a garden hose. If you take the end of the nozzle and you just got the water, it's just kind of flowing out, that's the amount of water. When you put a nozzle on the end with the spray nozzle, now we're restricting that and we're actually shooting it out. So we're actually adding a little bit of pressure behind it. So think of it as a garden hose. For here, constant current, that's what we're going to be using. There's a couple different type of constant currents that we're going to be using in our stick welding process. The first one is DC electrode negative. DC electrode negative is a little bit different than what we've been using for our wire feed process. All your wire feed processes were typically DC electrode positive. What is DC electrode negative? Now, when you start thinking about currents, think of a magnetic field. You have a positive side and a negative side. For electricity to travel, it travels from negative to positive. It creates a circle. You got to have a circle, and it has to be complete. That's why you have your ground clamp, your electrode. When you strike that arc, you're generating that electrical current in a circular way. So here's my power supply, my welder, positive terminal, negative terminal. Here's my base plate where I'm going to be welding. Electrode negative. One way of keeping this simple. So your electrode holder, where you actually put your stick electrode, is going to be on the negative terminal. Electrode negative. My ground clamp, where it actually gets clamped onto my workbench or the piece that I'm actually welding on, is going to be positive. So, current actually travels from negative to positive. So as we go and strike our arc, the electrons are flowing from my negative terminal to my positive. So, let's look at this in bigger terms. So here's my stick electrode. I'm going to amplify it. Here's the piece of metal I'm welding on. That is negative. Electrons travel from negative to positive. So all electrons are flowing through your stick electrode and be dispersed on the piece that you're actually welding. For the welding process to actually occur, the restriction of that electron flow, that's how you generate your heat. Think of it as a fuse, like in your vehicle. It gets an electrical surge, a lot of current goes through there, restriction, melts that fuse, and everything shuts off. That fuse is the whole idea, it creates a short circuit. Same thing here in all our welding processes. So as our electrons travel through here, you notice there's not a lot of restriction. You're going from a small surface area to a big surface area, so the flow is very, very easy. There's not a lot of restriction. You're not generating a lot of heat. Typically for SMAW, DC electrode negative is not commonly used. The main reason being, we have 70% of our heat at our base metal, and 30% of our heat is at our electrode. So basically all your heat is going to your base metal, and your electrode is not heating up near as much to generate fusion. So when we get into our stick welding class, basically all of our electrodes that we're going to run are going to be either AC current or DC positive current. So that's DC negative. Let's go over DC positive. DC positive is basically just the opposite. Direct current, keep that in mind. So that current's going to be traveling in one direction. Here's my welder, positive, negative. Here's my base plate. My ground clamp. Now I have my stick electrode. So like I said, everything's going to be just the opposite now. So now everything's coming from that negative terminal, going into that positive. And it's going to go up through here, complete the circle. So as you can see, our electrode, all these electrons are floating out throughout this plate, and they're being forced into your electrode. So you go from a small or a big surface area into a small surface area, generating a lot more heat. So here we have 70% of our heat's at our electrode. That's what we want. 30% is in our base metal. So with DC electrode positive, we're generating a lot of heat. We're going to get more fusion running DC electrode positive than negative. It comes down to that surface area. You're going from a large surface area to a small surface area. Generates a lot of restriction, generates a lot of heat. Just the opposite of DC negative. So when you weld it with your 6010s, 6013, 7018, we're going to be running all DC electrode positive. Main reason being because we want that fusion. We want to generate a lot of heat at that electrode in creating that fusion. Now just the opposite in TIG. Primarily in TIG, we run DC electrode negative. It's because we do not want to burn our tungsten electrode. So kind of keep that in mind. It's all about that circular current. It's going to generate a circle, a magnetic field, negative to positive. So all our electrons are going from our ground clamp up into our electrode, creating a lot of resistance. Therefore, that's where we get our fusion. Now, our typical welding currents that we're going to be welding at are basically, what kind of temperatures do we actually welding at? For stick electrode, we were welding probably around 5,500 all the way up to 36,000 degrees Fahrenheit. Now, you being a welder, you typically want to weld as cool as you can. Number one, because you want to restrict distortion and things like that. You don't want to burn all the alloys out of the metal, so we try to weld a little bit colder than you would in any other application. So keep that in mind, DC positive, that's what we're going to be running. That's what your wire feed processes are, primarily DC electrode positive, because that's why they want to generate a lot of heat at that electrode, creating more fusion. Now, also in stick electrode, SMAW welding, we also use a current, what is called AC. What is AC? AC is alternating current. So what does that mean? Here's my welder, positive, negative. Here's my base metal, stick electrode coming down. Here's my ground clamp. Alternate current means that it alternates from DC positive to DC negative. So it doesn't matter where I actually have my terminal hooked up into, because they're going in both directions. It's going in both directions. The machine automatically does this for you. So it alternates between DC positive, DC negative. So you actually have a little bit of a cooling cycle. So you have 50% at your electrode, 50% at your base metal. So as you're welding AC, you have a period of time where it's DC positive and another period of time where it's DC negative. Typically all your newer machines, they call it square wave. We do use AC a little bit, not too much, but when you look at typically all your newer machines, there's what they call square wave technology. What does that mean? So this is my positive, negative. So it uses a square wave and it alternates negative, positive. So half the time we're in DC positive, the other half the time we're in DC negative. It happens very fast. You probably don't even realize what's going on, because it's happening at about 120 times per second, and it switches. So yeah, negative, positive, negative, positive, negative, positive, negative, positive. That's what current is. It alternates from negative to positive, positive, negative. It does not matter. Now, like I said, it's a little bit cooler welding process because you're not generating near as much restriction. It's 50-50 as you distribute the heat on your electrode and your base metal. Now, when you actually get into the lab and you start welding, there's a thing that's called arc blow. Chapter 3 gets into a lot of technical terms about the welding power sources. I'm not going to dive into that. I want you to understand what the currents are and a few of the things that you may encounter in the lab. So as you're welding, you might get, so for example, here's I'm just putting a bead plate. You're welding, you get about 3/4 of the way through, and all of a sudden your welder starts acting really weird. You get a lot of spatter, your arc isn't maintained here as well. Well, they call that arc flow. What arc flow actually is, remember we're welding with a magnetic field. So what actually happens is the electrons, when they're traveling here, they get goofy. Here's my base plate. Here's my electrode holder. So as you're welding, your current wants to change because of that magnetic field. So we're welding electrode positive. I'm sitting here welding, all of a sudden, boom, I get all the spatter. Well, your current wants to start reversing. So that means your current wants to travel the opposite direction, but you're welding in one direction only. So that's what actually happens. Because remember, all we have is this circle. Positive, negative, and you're going in this circle. What actually happens is an arc flow wants to start reversing that circle. That's what they call arc flow. There's a couple different ways you can, what you can do to eliminate arc flow. Number one is move your ground clamp. A lot of times the old timers, they'd move the ground clamp as far away as possible as they could from where they're welding. That would actually make the current only go one direction. Another way to actually eliminate arc flow is to weld an AC current if possible, because you're switching it from negative to positive. It doesn't matter which one you're actually welding in. So that's arc flow. It's wanting to reverse the direction of the electrons, and it gets real spattery. Your arc starts to wander, maintain, and things like that. Another thing about stick welding and all welding processes is duty cycle. What is a duty cycle? Well, duty cycle is basically how much your welder can output. So what do I mean? Let's say your welder has a duty cycle of 60%. So 60%, that means I can run that welder at max output. So for example, let's say we've got a Dynasty 200s out there. I got a Dynasty 200. 200 amps is what that welder is rated for. So I can run at 200 amps for 6 minutes out of 10. That's 60%. That's what that means. Every welder is going to have a little bit different duty cycle. 100% duty cycle means I can run at 200 amps all the time. 60% means I can run, like I said, 60% of the time at that max rated output. Very important when you get into industry, because a lot of times you might be welding for 5 to 6 to 8 hours continuously. So here, typically a lot of your machines are 60% duty cycle. What's that mean? That means for 6 minutes out of 10, I can run at 200 amps, which is my max output. And then I gotta let it cool down for 4 minutes. Typically, you never reach the duty cycle out in the lab, because you're always either tacking something up, your machine's never running at max output. For example, if you're stick welding 7018, you're probably going to be set at 120, 125, maybe 130 amps. So you'll never reach that max output. So that's what duty cycle is. That's how long your welder can actually run at max output. Now there's a lot of other things in Chapter 3, a lot of technical terms. They get into transformers, rectifiers, and things like that. I'm not going to dive into the actual welding power source. The main thing is understand your welding currents, what they mean, what DC electrode positive means, DC electrode negative, alternating current, what's that mean? Another key term is arc flow. So when you're welding, you get about 3/4 of the way through your weldment, and it starts to act really weird. Realize that maybe you might have to move your ground clamp or weld an AC current. Understand your output of your welder. So when you're actually, if you want to purchase a welder for your garage, or you're doing some odds and ends out in your garage, Look at the duty cycle, understand what it can do. Remember, it's just the max output, the percentage of the output it can handle at max amperage. So that's basically it for chapter 3. It's more of an introductory. We'll get into chapter 4 and chapter 6 and chapter 28. Chapter 28 is all about stick electrodes. What are they made of? Why are we using this electrode for this base metal kind of thing? So I hope this was helpful. Also read chapter 3. Use your mind tap. Remember, mind tap is a very good resource for you. It actually reads the text to you. There's additional PowerPoints and videos in mind tap also for your textbook. Read chapter 3. Watch the video, this video here. Spend some time in it. It's very important that you understand how to set the welder up for whatever electrode you're using. I find that most of the time out in the lab, if there's an issue, it's typically that the student doesn't have it set up correctly. They don't understand what they're doing. If you get to that point in the lab and things aren't going well, contact your instructor. Thank you.